be a joint session with Lorenz Kasper, who is an NI employee, a very nice guy and a very good speaker. So we would have shared the time, this hour. Unfortunately, he couldn't make it because he has to attend another conference in Europe. So it's only us, the two of us. We will try our best to fill the time. All right. So my name is Peter Bokor, and my colleague. I'm joined by my colleague Barnabas Reischl. We work at a company called Inquiry Labs. Like I said, we are based in Hungary, in the capital city of Hungary, Budapest. And if you allow, I just very quickly introduce the company. So it's a software company. We have approximately 30 employees, so 30, and we build software basically. So we build tools for software engineers, mostly in the safety critical domain. So we also work with LabVIEW, so we build LabVIEW tools. So one of the tools is a unit testing tool for LabVIEW, and we will cover this tool as well in this session. So this talk will try to be objective, and we'll try to show you and explain to you the landscape of possible unit testing or of available unit testing tools out there. So one thing, so since a couple of weeks we are ISO certified, so hopefully it will give more trust about the tools that we build. This is a new result. Or it's not a result, but it's just a homework we did. So I'll do the first half of the talk, and Barnabas will then take over for the demo. We will also show you a unit testing demo. If you have questions, just interrupt and ask it the right way. So first of all, a small and a quick introduction to unit testing, like why we do it. The main motivation is very simple. So you have code in general, software, and you would like to test it. You would like to make sure that it's good quality. Now, unit testing, so the word unit means something. It's a bit, I would say it's a bit philosophical what it means. So bottom line is really we test software somehow. So we test software for different reasons. So the main reason is really to prove correctness, that the software is correct. So if we have, so this is a simple example of a calculator application. We have the divide function, and we just try it. So 6 divided by 3 is 2. This is a correct result, and we say that the test is passed. Now, obviously, so this is correctness. So this is a very important property of any piece of software. Now, completeness on the other side makes sure that you test everything. It's impossible to test everything, but ideally you would test everything. So if we test the divide function for 6 divided by 3 and it's passed and we stop, then we may miss cases. For example, the famous division by 0 case. So if the result is 0, we test it, then it's a failed test, and we covered a corner case. So completeness talks about really covering, basically testing everything, which is, like I said, impossible, but at least you should try it or make a compromise somehow. That you also have something, have some sort of completeness while testing. For example, so one compromise. So like I said, exactly. So you have to make a compromise, and people came up with compromises and formalized the compromises. one compromise could be to define equivalence classes, and then you say, okay, I try, if it's a divide, then I try like that the two operands are positives, both are positives, both are negatives. And I try positive against negative, negative against positive. And then I come up with some equivalence classes, and then I take one representative of each equivalence class, and then I test the software. And then in this sense, I have some completeness, because I completely covered all equivalence classes.
But that depends on the correctness of the decision of the possible values of the classes or ranges. Where this is similar to that. That's an assumption. How do we verify that? How can it?
Yeah. Yeah, so there.
Zero is apparently an exclusion in this case, and all other numbers is enough to test with one of them, right? Out of the range. Well, maybe positive, negative, but zero is an exclusion here, right?
Yeah.
How can you know in advance into what groups of values should you break your range?
Yeah, so you don't know. I mean, there are approaches. For example, we will see the code coverage, so you can make sure, for example, that you cover all branches in your code when you do white box testing. So this is an approach. This is a best effort approach, but in general you cannot. I mean, we are in the industry, so we do testing. So there is a more academic approach to proving correctness of software, which is a formal verification, for example, model checking or theorem proving. So model checking basically is an exhaustive approach. It really goes through all inputs. Okay. It can be feasible if you do abstraction. For example, you can use like very advanced static analysis and SAT-solve, so SMP solving, for example, so mathematical solvers, which make sure that they analyze your code and they don't have to try everything. So they have a smarter approach to do it. It's not the execution-based like verification where you just try and make sure it's the correct output. Okay, but this talk is not about that. It's not about exhaustive testing. We do like traditional testing. Okay, so the units. Yeah, so if you combine things, if you build a more complex software, then you build smaller units and then you test them. So this is like the hierarchic approach where you test like smaller units and then you combine already tested units. If you don't do it, for example, if you have this function, if you wrap, for example, this adder, and the results, so basically you add 3 to the result of another function, which is a divide. And if we have this failure in the application, then the result is 3. So 3 plus 0 is 3. And you don't really know if it's the add or the divide which failed. If you just, test this combination of functions. Now, what people do is that they first. I mean, this is an approach that you can do. Is that you first test your units, and then you combine units, and you can make the assumption that the units are tested correct. So this is kind of a divide and conquer approach, which you all know. It's quite trivial. So unit testing. So software testing. Software testing. What is unit testing? So like intuitively speaking, it can be said that unit testing really focuses on like smaller units of your more complex system, and then you basically trigger the inputs, and you see what the outputs are. You make some comparison, and you decide if it's pass or fail. So this is like the very intuitive introduction to unit testing. Okay, here is a LabVIEW example. So this is some code, some random code, and the red VI is a critical VI, and you see that the reachability of this VI is probably not trivial, because it depends on whether or not you end up being in this case where the critical VI is executed. Depends on a lot of things. It depends on the string input. It depends on an object. It depends on the error cluster. So we have two challenges here. The one challenge is to write a test, so come up with inputs. So the three inputs are again string, an object, and an error cluster, so that you actually execute the critical VI. Okay. So this is manual labor, not always. I mean, so there are techniques that this can be optimized. We are at an NI conference, and for LabVIEW there is no automation for that yet. So this is a manual labor, so to come up with these inputs. Now, the other challenge is, so the tester thinks to have these inputs so that the critical VI will be executed. Now the other challenge is to make sure that this is the case, to somehow monitor the execution while testing, and make sure that this is indeed the case. So the critical was executed or not. Now this can be optimized because you just have to monitor the. So it's conceptually it's not hard to do. I don't know. You can imagine you put probes on the cases and so on, and you somehow monitor if the critical VI has been executed or not. Now, this has to do with coverage and completeness. The previous foil we talked about completeness. So basically, code coverage says that I would like to make sure that I cover all cases or structures. So you can define different metrics of coverage. So there is in the test books you can read about branch coverage, path coverage, and other project coverage. So there are different definitions of coverage. So if you are familiar with the unit test framework, which is the native unit testing tool for LabVIEW by NI, it supports code coverage, which we call it, I call it, it was in German, custom coverage. So custom in German is some structure. It can be a case. So it's basically a frame, and basically a frame. Let's call it a frame coverage. So you basically cover. So you have 100% coverage in terms of the unit test framework if you cover all frames on your VI. So in this case, it would be the first case structure. Let's say it has like 2 or 3 cases, then I have to cover all of them. In the second, it's true and false. So it's basically 2 cases. I have to cover all of them. So if I have a test suite which consists of multiple test cases, then this test suite would cover all frames if there is at least one test case for each frame which basically enters the frame. Now, if I have 100% coverage for this code, then I can be sure that the critical VI was executed in at least one test. Okay, so again, the message here is that to come up with the inputs to explore the critical VI is it's basically most of the time, if it's a tricky combination, or if it's tricky to do that, then it's basically for the programmers. It's only the programmer can do it because he or she knows the code and knows how to explore that one. and to check if it's really the case, if I have coverage, if I have 100% coverage, is an easier task. Yeah, so why coverage? Why do we care about coverage? So like we said, it avoids untested code. So you have at least in terms of the definition. So if it's a frame coverage, that I cover all frames, that I don't have a frame which is not tested. And I also prove reachability. So this is a nice thing about it. So basically, you prove that you don't have that code in your LabVIEW API, because you basically prove that the test cases are evidences that you can explore those frames, those parts of the code. I mean, obviously, it's not very good that you have some complicated algorithm, which a sub-VI, which you call somewhere in the user VI, which uses this algorithm, but the algorithm will never, execute it. Okay, so coverage is required by standards because it really ensures some correctness about some quality of your software, and required by companies. So some companies, so we have a project with Bosch, where we develop an HIL system with them. So this is basically a test system. So they use this system to test their products, and still they have the requirement that the code of the test system, so every commit needs to be tested against. So it needs to have this criteria that is 100%. So the code is tested against 100% coverage. So tool options. So this is a big table with lots of data. So basically, it's a good reference for you. So this is also on our website. It really tries to be a very objective comparison. Yes, the tool options you see here: the unit test framework by NI, the VI tester and Karaya by JKI, and an Instacoverage, which is our tool. But really, it's supposed to be a very objective comparison. So if you think it's not fair, then please give us feedback. We will fix it. So I would like to walk you through this table, maybe. So this lots of times we get so people approach us and ask us about about the best choice for them, for their needs of the testing framework. So it depends on different things, and this table hopefully helps you a bit with your decision. So first aspect is the model, so the testing model. So these tools more or less cover two testing models. The one is what we call the X-unit style, which is, if you are familiar with unit testing, but these are very intuitive concepts, so it's very easy to grasp. So basically, X-unit style, by X-unit style we mean that you have a setup, you have the software under test, which is the V under test, and you have a tear down. So the setup is there to prepare your test, then you execute the code under test, and then you shut it down, you close things, you evaluate the result, things like that in the tear down. And the harness is basically, so this is the harness, like the setup, the software under test, and the tear down. Now another approach is the assertion. So you see that except Karaya, pretty much all of the tools apply this paradigm. Except Karaya, which is what we call assertion-based. So basically, you know assertions in other programming languages. So basically, you put in your code asserts, and you check something. So you don't have this triplet of setup and V under test and tear down. So maybe here I would mention one more aspect, which is like the first footnote, I guess, that you have this. This has to do with. It's not really like a feature. It's maybe it's a feature. It depends on how you look at it. So it's basically how you structure your tests, how you structure your test project. So explicit test configurations. So if you know the UTF tools, the unit test framework, you know the LV test extensions. It's basically an explicit configuration file where you set up your test. We have something similar in InstaCoverage. So it's an InstaCov extension, and it's basically an XML. So it's serialized into an XML file. And it basically, it's similar to LV test. It's the configuration of your tests, and this can be very helpful because it's a very compact way to store your test configuration, and you can have it. You can structure your project in a way that you isolate. You basically separate your production code from the tests. And these like assets help you with this structuring. The other tools don't have these configuration files. Again, I mean, it depends on your needs if it's helpful for you or not. We found it helpful, and that's why we implemented. So it's basically we copied this paradigm from the unit test framework. Now maybe, yeah, it's more of a historical comment that NI basically decided to discontinue the development of the unit test framework. So you'll see the last aspect in this table is if the tool exists for NXG or not. The unit test framework does not exist for NXG, and it will not exist. So this is a decision that they did, that NI did, that they would like to let the community build unit testing tools. Yeah, price-wise, the unit test framework is so you can buy it, or it's part of your professional, so LabVIEW Professional Edition. VI-Test Sakaraya is free. And InstaCoverage comes in two flavors. The one is a so-called Core Edition, which is free, and the other one is a Professional Edition, which you have to pay for. And later we will see the differences. This is like the feature set of this of InstaCoverage Core and Pro. Code coverage. We talked about code coverage. Yeah, so the unit test framework supports code coverage. The InstaCoverage Pro supports code coverage. And actually, yeah, in like 1 minute ago, I said that later I will show you the differences. So this table already shows like the main differences across the InstaCoverage Pro and Pro as well. So code coverage, yes. So unit test framework supports it. InstaCoverage Pro supports it. The other tools do not. Now, you may wonder if you need code coverage or not, or need it at all. So if your process requires it, then it's good to have, or it's not really a choice. Either you implement it yourself, or you have a tool which does it for you. And we will see an example which shows that this can be handy even if it's not a requirement for this. Scalability, what do we need? What do I mean by scalability? It's basically the execution time of your tests. So if you ever use the unit test framework for big projects, it turns out that it's very, very slow. So in fact, this was like, back then we started like two years ago, the InstaCoverage project. The main motivation was for us was to figure out why the unit test framework was so slow, and we wanted to have a tool. Basically, we have so this the project we do with Bosch. We work with big LabVIEW projects, and what happened? It wasn't me, so it's not like it's not part of the show. Okay. So, so the main motivation was, so there it was really a pain in the ass, sorry to say that, but, okay. Is it us, anybody in the room, or is it, okay. Okay, yeah, so for us it was really unacceptable, this execution time. So we have these big projects, and we have to wait hours for the test to execute. So this is scalability. Now you see that the UTF, for some reasons, I mean, we kind of know the reasons, is slow, and the other tools are fast. And so we first thought that the measuring of the code coverage is inherently a hard problem in LabVIEW, but it's not. It turns out it's not. You see, I mean, we do code coverage, and we support the same semantics, like the coverage semantics, like the unit test framework, and we are still pretty much as fast as the other tools who do not measure coverage. Yeah, support for real-time target. So it's similar to coverage. So the UTF supports executing the unit test on a real-time target. The InstaCoverage Professional supports it. The other tools do not. Source code availability. So the good thing about VI Tester and Pariah, obviously, that they basically they have their source code on GitHub, so you can see it, use it, tailor it to your needs. The unit test framework is proprietary, so you don't have the source code with the license. And InstaCoverage is similar, except that we call it the inspection model. So if you need it for, if you would like to customize it, you can do it, but you cannot build upon our code and prep it and redistribute it or sell it or something. It's really for your needs. So if your business is totally different, I don't know, you build sensors and then you use this, you need a customized version of InstaCoverage, then it's okay, then you can get the source code. API, so the programmatic execution of the unit test framework or the programmatic usage of the unit test framework. So except InstaCoverage Core, all tools support it. So this is good for continuous integration. For example, if you have a Jenkins server and you would like to automatically execute these tools, then you can do it using an API. And I mentioned the NFG support. So the only tool exists. So InstaCoverage Pro is so tomorrow we have a meeting with an R&D, and we will see if they can provide the necessary interfaces in NXG so that we can implement the Pro features in InstaCoverage. But the core version is already available for NXG. It's the second version already. It's I mean, we know that it's not. It's the future, NXG is the future, but we are preparing for the future. We really like to show that we are planning with NXG, for NXG as well, and we have an NXG version already. Any questions for this table?
Not about this table, but I wasn't able to figure out what does this unit test give me. Because I'm doing some unit test in my code, I'm giving the input, I running the code, and then I check the output with some software. But usually it's on a basic unit that need to be tested. What does this one do? Like usually those things are not standard. You have to give the input, the output, and then run.
Yeah, maybe we can come back to this. So we will show a demo, and you will see what tool adds. So what's the the added value of the tool, and you will see if it helps or not for your application. But in general, it gives you, it generates. You will see that you have the VI under test. You push a button, and the tool will generate the template, the test template. Setup, the teardown, the harness, wiring, things like that. So it's basically, it's not rocket science, it's not a time machine, it really gives you, it just accelerates your software development process.
So does it assume that the API that has is purely transformational? That, okay, so that it takes some inputs and then it gives you some outputs. What if that API inside, it doesn't take its inputs from, say, controls or connectors, but say it has a TCP listener, it receives a message, or even a queue, it listens where it gets its input from another API that's sent to that queue.
Yeah. So we don't make as long as the VI can be executed. So we just and it's similar to the other framework as well. So the unit test framework will just execute your code. If the code is executable, you make sure in your setup that if it's a TCP connection, if it's a queue, if the VI is not, the VI under test is non-blocking, so it will at some point get these inputs, then it works.
I understand, but the value of such frameworks is that it will automatically vary the value of some input, right, to test over some range, right? This board lists some sampling of the possible input values. It will sequentially change and see how the AI performs this value of that input, for that value of that input, for that value. But I'm asking, does it assume that all those values come through just say control, or can it somehow take into account that those values come in and change the behavior of the AI, because it may take different routes depending on those values too, right?
Yeah, so like I said, we don't make assumptions on the source of the data, and other tools likewise. So it doesn't have to be a control, it can be any data. But we don't, so these tools will not take care of the combinatorics. So you have to, so the tester has to write, so basically prepare the inputs and make sure that those inputs will be available. So so this automation is not supported. But we can maybe, if it doesn't answer your question, then. Maybe we can see what the demo, how the demo is, and then if it's not clear enough, then we can discuss that. Yeah, so this is, I don't know if we are probably we are not the only one who participate in this. So this is for the SEPAD session. So this session is part of a series of like skill development presentations or sessions, and so the plan was that we also cover basically a running example, which is for NI. It's used for training purposes. It's a board with microphones. It's able to receive audio data, and that does something and output something. Now this is like, you can call it an HIL setup with a MyRio, which is basically used to send data to the board and receive data from the board, and it can also trigger a speaker basically, so that the board can be like triggered and some audio signals can be sent to the board. You can see it on the table. It's set up. Now, without the speaker, so you are the speaker, you can talk to the board. And then there is some code, so it comes with some LabVIEW code. So the LabVIEW code is being executed on the MyRio. And we basically, so what we did, so we took a VI, more or less randomly, which is the VI under test for us. So this is just a demonstration, like I said. So every SEPAD session is supposed to cover this example and show that the topic of the session, how the topic can be applied to this running example. So this VI we selected is basically a configuration logic to configure this in the middle. You see in the yellow frame, basically it sets the clock rate on this electronics. And this VI, like I said, it runs on the MyRio. And we define two test cases. One test case sets an in-range clock rate. And then in the teardown, we see that the result is expected. We have no error. And the board also outputs a chip ID somehow. But the main test case is really, the main message here is that we have like an error-free, so a correct test case, and an erroneous test case, which is the second test case, which is an out-of-range clock rate, and then this clock rate cannot be set, and then we get an error. Now we run this test, and we see that that we don't have 100% coverage, so we can use for this experiment, we can use the unit test framework or instant coverage with code coverage. So actually this is, so we thought it's a good example that even if you don't need test coverage for your process, for your certification, it can be handled. Why? Now I would expect that these two test cases cover all my frames in my code, right? Because I covered like the two main scenarios in this configuration logic. Now, if you look into the VI, so this is the VI from NI, or which is shipped with this training project. So we see, so the tool will tell you, will point you to the frame which is not covered by any of the test cases. And it turns out that this is the test case, which is, so this is the frame which is not covered, this case. And this is a kind of a fault tolerance, so it's logic for, it's basically fault tolerance built into this VI. And because sometimes you have to do the write, so the reading, you read basically from an FPGA, and sometimes you have to do it twice for some reason. And the developer doesn't really know when it's the case. So sometimes it's enough to do it once, sometimes you need like 2 attempts. Now, but the test case is, so this test didn't, so during this test you didn't have this bad case where you needed 2 attempts. So it's basically a kind of a hint that you don't have the full understanding of your setup, because you don't really know how to reproduce this bad case where you needed 2 attempts. So coverage here gives you a hint. Okay, here there is something fishy with your knowledge and understanding about the system you are testing. Okay. Now the demo. Yeah. So before the demo, let me show you something which is basically. So for the demo, we will use Insta coverage. So this is maybe a bit biased, but it will allow us this small light bias. So this is the Insta coverage website, and here you see it's not about the pricing, it's really not about money, it's about the features. So you see that Insta coverage comes in 2 flavors, Core and Pro, Core on the left side, Pro on the right side. And we talked about the features, and you see here that so the green buttons mean that it's already available. So for Core, we have an NXG version, and Classic is not yet green. It's in the process of NI accepting this add-on. So it will be green as well. And for Pro, Pro only exists for the Classic version, and like I said, we are now in contact with NI so that they can provide us the interface that we need so that we can implement Pro for NXG. And we won't show a demo for the NXG version. We have a couple of screenshots here. You can try it if you have NI Package Manager inside. NI package manager installed, then you can install it and try it. So you see it's, if you go to maybe next. Yeah, so basically it's in sync, so like the look and feel is in sync with NXG. So here you see what we generate. We don't have time for it. Maybe if you go to the last screenshot, you see that after executing the test, and you have a report view. So no surprise here. It's just really just to show you quickly that the NXG version is out there and you can try it. And now we'll switch to the real demo, which is going to be the demoing of the InstaCoverage Pro for current gen LabVIEW. And this is not so this is the latest version is already available, but this is a beta version where we would like to show you how we help you with wiring the VI and the test with the setup and the teardown, so you don't have to. So basically, we analyze so we use VI server functionalities. We analyze the VI and the test. We understand the inputs and outputs, and we pre-wire them with the teardown and the setup VI.
Okay, so hi everybody. Can everybody hear me?
Yeah.
Okay, that's good. So we had prepared a demo project, but we heard in the NIWeek that one of the new features of the LabVIEW 2019 is the error management case structure. I'm not sure that everybody heard about it, so I can explain it shortly. That this is a case structure when you can, as case structure, wire an error in, and here you have a no error case, and here you can implement an error with the code. So if you type error and then a number, for example 42, then it will enter this case when you have in the error cluster the true constant and the code is 42. So we will, and the third option is this default when the other error cases are executed. So I will create a unit test. First you can see that I entered other strings which are the output of this VI, and from these strings I can check if the executed, which the executed case was. You can see in the front panel that I wired the error in, and so I connected the error in and the string output in the connector pin. And now I will...
Sorry, just one more comment to make sure that it's clear. So we use now LabVIEW 2019, and we would like to test one of the new features of 2019. So it's really, the VI itself makes no sense. It really just uses this error, how's it called, error cluster management feature, where you have this syntax in the case error and the number, and the number is the error code. Yeah. So this is the VI and the test.
So here I can generate a unit test for it via right-click, InstaCoverage, and generate unit test. And first it will ask for the folder in which I want to save the unit tests. So in this folder I save the generated artifacts. And here you can see what are generated. Here we have this configuration file in which you can see the path of the VI under test. You can see the path of the harness, which is also a test artifact. And here you can set up test cases. Here you can add comments and requirements to the test cases, which are not required, it's just optional. And now from here I can open the harness. And here you see that here are the VI under test. And there are a generated setup VI and a teardown VI. So the setup VI is for preparing the unit test, and the teardown VI is for evaluating. So here we can.
Sorry, Barnabas, just one moment. So this is what we generate. So this is what the unit testing tool generates, and you see that so in the current version, the wires between the setup and the VI test and the VI test and the teardown is not generated, so you have to do it. Now in this beta version, and it will be available in the next couple of months, we already generate, so basically for all inputs of the VI test, we generate the wires, and for all outputs of the VI test, we generate the wires. And also in the setup and teardown VIs, you have those controls and indicators. So this is just, you could do it as well. If you have like lots of inputs, outputs, then it's time-consuming task, and we do it for all combinations.
So guys, you're doing it, or you doing it?
We do, so in
You're doing it in next gen software?
no, so this is for the current gen, so this is, we have like releases for the current gen, and we have releases for the next gen.
Okay.
Now, we are talking about now releases for the current gen.
Okay.
And in the current version, we don't have the pre-generation of wires
Okay.
in the release today. But we have the beta with us, and we show you what is going to be inside the next release, which is due around June, July.
Okay, so here in the setup, there are the test case ID wired in, and in this case structure you can set up which test case from the configuration editor you want to execute, and here you can set up the inputs for the VI under test, and also in the teardown VI you can check the results. So here you see this string input, which is the output of the VI under test, and if you want to test, then you can check the results and evaluate the results, and also here you can clear the environment which you can set up in the setup VI, and also in the setup VI you can set for example queues, and here you can enqueue the element or the elements which are required to test the VI under test. So if you queue here an element, then you can read it after, so it will be available in the VI under test, and also TCP connections and the others. So right now I should implement the test cases, because I want to test all of the case structures here, but I think that it should take about 5 minutes. So
sorry, Barnabas, before we go to the next step, if you open the teardown, so in the teardown you see that the output of the teardown is a Boolean result. So this is part of the framework. So this is basically if the test is passed or failed. So you have to evaluate, the implementer of the test has to evaluate the output of the test case, and the result of the evaluation is this Boolean, which you have to tell the framework. So here in the teardown you do two things. You shut down the test, you can destroy references and so on, and you evaluate the result of your test case. And now we jump to another project. So basically we prepare the test cases for you, because it takes a while to click them together. And we open another project with the very same VI test, but with the test cases prepared.
So here is the VI under test. You can see that this is the same, and so in the setup we implemented 3 test cases, which are the other, which adds the inputs as required in the VI under test. In the configuration you can see that there are also these 3 test cases, and now I can run the tests from the IDE with this insta coverage button. Here I can create also report files, so for example HTML, which can be saved somewhere, and it opens. And here we see that in this test suite we have 3 test cases, and all of them are passed. And also we see that the coverage is 100%, so the aggregated result is also passed. So our approach is that a test suite is passed only if all of the test cases are passed, and also the coverage is 100%. You can use different approach. I will show it later. Oh, sorry. So here you can also see that all the test case results are passed and the code coverage is also 100%.
Sorry, yeah, so what you just said, so if you don't like the segregation, and there is an API, so you can use the instant coverage API to implement custom aggregation logic. So basically, yeah, you have access to these sub-results, and then you can implement your reports as needed.
Yeah. So, and now let's assume that you have to change something in your source code. So, for example, you have to add another case in this error structure management case structure. So I can duplicate this case, but the error code is 43, and also I changed this string to 43. And if the changes in the source code are ready, you should test it again, because you have to be sure that you didn't broke anything. And now I run the test, and now I don't generate any report file, and I see that the status is failed and the coverage is not 100%. So although the test cases are passed, but you can see that here are one uncovered diagrams. I can open it, and here we see that the newly created case is uncovered. So right now I can fix the test also. So I should open first the configuration file, and here I can add a new test case called error 43. I can save the configuration and open the harness VI, and from it I can open the setup, and here I can duplicate this case and rename it error 43.
Yeah, sorry, so this is another improvement we plan to add. So you see, you can add a new test case in the configuration editor, and we don't synchronize with the code base yet. So we could also add the setup and the teardown, the new test case ID, and then the programmer only needs to fill the test logic. Right now it's a manual task as well, so this is a planned improvement.
If you have more than 2 inputs, you will need a separate case for any transform calculation.
Yeah, you will need expected. So you have to, no, sorry. So you have to implement different cases for all the tests
All the combination
of the inputs.
Yes.
Yeah.
Yeah.
Yes. And so now I have to create this new test case in the teardown also, because it's the part of the whole test. It's also error 43, and here I can change this string as required. I can also save this, and now I can execute the test from this configuration editor also. Oh, it seems that we have a failed test case. The reason of it can be that I mistyped something. So here I open the harness and the setup management. I see that I didn't change the error code in the setup VI, so I change it right now and save it again. Close the runner window and run all test cases, and now you can see that this case was also passed and the coverage is also 100%. So I fixed the test based on the modification on the source code.
Yeah.
Can you run highlight execution through a test somehow?
Sorry.
Can you run highlight execution through a test if it fails? Or?
Yeah, so if you turn on the highlight execution, and so now I run so I put it here, it will be visible, and I run the test, then you see that the highlight execution is working as well. I hope I answered your question.
How did the coverage go? Like, was it inspect? Did you use all the cases within something like API, or just like
So we measure the coverage of the VI given here in VI under test. So we measure the coverage of this VI.
It's not recursive, so it's not.
So it's not, yeah.
No. It's the same coverage semantics like the unit test framework is using. It's an option, so if we now go to the roadmap, so we have to close the session at some point. Yeah, so this is the roadmap. It's in an insight, so basically it's more for us how we plan the rest of the year and what releases we plan to have. So we have, so this release around the end of the year or early 2020. So we would like to add a new, so alternate, basically new coverage semantics. So right now we have this frame coverage. We would like to add project coverage, which is slightly different. And this would be like the recursive measuring of coverage. So that we go into sub-VIs would be another idea to that. Yeah, it's been, so I guess earlier it was called the VIP in Munich. So this is basically the NIWeek of Europe used to be. Now they renamed it to NI Europe, I guess. So if I'm not mistaken. Yes, it's a big event. It takes place in Munich. Nice event. It's very similar to the NIWeek. Yeah. Yeah, and maybe to close the session, I can tell you one thing, which is a very ambitious plan, but I would like to have it at some point, or we would like to have it at some point, for, which is basically now we generate things. We basically generate only templates. So we generate. So we have the programmer. We generating templates like the setup, the tear down, the wires. But it could be done by the programmer as well. It's just saving money. Now, one thing would be very cool to have is to generate the tests themselves, so that we look into the VI and the test, we understand how to exercise the different frames, and we would generate the inputs. Okay? And imagine that you just push a button, and then the tool would generate all the necessary inputs, all the necessary test cases, so that you have 100% coverage. And then the job of the programmer would only be to do the comparisons, the expected, so the reference, so the actual and expected value comparisons. So this would save enormous time. So you have a complicated, like I showed you this complicated path to a critical VI. And you don't have to think about it, how to reach it. The tool would generate it. And this is state of the art. So this is possible. So it's called, so the underlying technique is called symbolic execution. It was an academic result, a computer science result, I don't know, 15 years ago. It's now finding its path towards industry as well. It's a very pragmatic approach. It works it's reliable, and you can use like SMT solvers and the symbolic execution technique to do this code analysis, to understand the code, and to come up with inputs. And these wouldn't be just guesses. It would be guaranteed, and it would terminate. So, no, I mean, it wouldn't know for a division or for your application logic what is passed or failed, but at least it would generate test cases which will exercise all frames in your code.
Right, but to exercise without knowing whether it passed or failed is pointless. But to determine whether it passed or failed, you need to know the expected value for that.
I mean, you can use AI maybe, but if it's pointless or not, I guess it depends on what you want to achieve. So if you would like to rule out that code, then it's not pointless, because it can rule out that code, right? Because if it's impossible to generate inputs, if this like magical oracle wouldn't be able to generate inputs for a certain part of
to make sure that code is run. So
yeah. But it's not pointless.
But somehow figure out, for example, the combination of inputs that would trigger that particle clock. But then to validate this whole thing, still you need to determine whether the expected output
You're right.
with that part of code engaged equals to the actual output.
Yeah, I mean, you have to start somewhere. I guess it would be a big step forward where you can pre-generate those test cases, make sure that you cover all frames, it's all automatic, and then the programmer's part would be to do the comparisons, because he or she knows the application logic and knows what the expected, yeah, exactly. So, I mean, this would be possible. It wouldn't be a deterministic approach, I guess, to guess the expected output, but this is like even more future. So for me, it would be a very nice next step where we can generate the test cases, pre-generate. Right now, we just generate templates. Pre-generating test cases which work and which guarantee to have 100% coverage would be a nice step forward. Okay, so that's it. Thanks for your time. We have flyers of Insta coverage and a brochure of our company if you're interested. And after the session, I'm happy to talk to you if you have further questions. Thank you very much.